Hey guys, welcome to day 9, or as we call it, quiz day. So this is about the day that I would normally be giving you a quiz on some of the more complicated area things that we've been learning. So what we're going to do today is we're just going to go through the quiz questions for practice, and you're going to treat it as a quiz yourself, check in with what you know and what you don't know. So I've got a copy of the quiz on Google Classroom. So you can go ahead and either print it out and do it, or you can do it on a piece of notebook paper. I'm also starting a new thing to liven up the mathematic videos of having a math meme of the day. So here's our math meme of the day. Why do pizzas come in a square box, made as circles, and eaten as triangles? A very, very weird thing to think about. And I thought it kind of went nicely with what we're doing here with looking at polygons, breaking polygons up into triangles. So kind of a fun thing to think about. And now I just really want to eat some pizza. So here is our quiz questions. So these are normally what I would be asking you to do. The learning standard is finding the area of a triangle, polygon, circle, and use those ideas to find areas of shaded region or composite region. And the first one's the first couple are pretty straightforward problems. So this one asks us to find the area of the octagon. And remember our strategy, our first step is we do area of one triangle, and then we do the triangle times number of triangles, right? That triangle area times however many there are. So if I look here, I can find the area of this yellow triangle really nicely. They've given me some good information. They've given me the base is 12 and that the height is 14.49. So if I was to plug that in, my base times height divided by 2. My base is 12. My height is 14.49 divided by 2. So I'm going to pull up my calculator real quick. Give it a chance to load. Okay, so 12 times 14.49. divided by 2. And it looks like it's about 86.94. I'm going to leave all the decimal points there because that's my area of one triangle. And then I have to take that area and do 86.94 times 8, because being an octagon, there are 8 triangles that make it up. So let's see what it is. It looks like it's 695.52. And I'm going to write units squared, because I don't know what my units are. Sorry guys, I got a little cramped there. Okay, so I did my step 1, finding the area of one triangle, right? And that's kind of this area here using your base times height divided by 2, and then times 8 because there are 8 triangles in my octagon. Okay, so that one should be pretty straightforward after you've done some practice in your homework. Number 2 should also be a pretty straightforward question, just like a quick check-in. Do you remember the area of a circle formula? And remember our formula is pi times radius squared. Now my radius is from the center halfway across, so I'm going to have to take half of 12 or 6. And my area is going to be pi times 6 squared. And we're going to write that as 36 pi. Remember the reason I write it like that rather than pi 36? That's kind of like writing x 36, right? We normally put the 36 in front of the x. And in this case, they did give me units. They gave me centimeters. So I'm going to say centimeters squared. I prefer to write it like this in terms of pi. If you wanted to find the decimal approximation, you would have done 36 second, the little caret to get pi. 113 point, I'll say maybe 113.1. 113.1 centimeters squared. And just like an interesting thing to point out, I'm using the pi button there. If you were to not use pi button and use about 3.14, which is totally fine, I just want to point out that you will be off by a little bit, but that's okay. If you, in your calculations, were to show me that you just did it times 3.14, then you would be all good. But it does make a difference using the button versus writing 3.14. Okay, so far those problems I would say are like pretty core, right? There's not a lot of funny things going around. It's just like straightforward. Do you know how to do the area of this shape? And I would say number 3 is also a core problem. This one is one of our, if I look up at the top, I've already done a polygon, a circle, right? Triangles are kind of part of polygons. So this last one's going to be a composite figure, which is like putting a couple things together. So the composite shape is when you put multiple shapes together and you have to find the area of each of them separately. So this one you can actually do it a couple different ways. Option number 1 is you can find the area of the rectangle and the area of the triangle and add them together. Option number 2 is you also could look at it like a trapezoid and use your trapezoid formula. So I'm going to show you guys both ways. So option 1, which would be rectangle plus triangle, right? My rectangle, it looks like my base is 6, right? Not 14. 14 is all the way across. And then my height is 5. So I'm going to do 6 times 5, right, which is 30 centimeters squared. My triangle, it's going to be base times height divided by 2, right? My base is this little bit. Notice that's going to be the total of 14. Take away the 6, right? Because 6 is going just until you hit the end of the rectangle there. So if I subtract that, I'm going to get 8. So my base is 8. My height, how tall it is 5 divided by 2. You're going to get 20 centimeters squared. And then you can add them together and get 50 centimeters squared. So that's option number 1. Option number 2 would be that you could use your trapezoid formula. And that one, remember, is a little bit more complex. Your area is base 1 plus base 2 times height divided by 2. And my two bases in this case are the 14 and the 6, right? They're the two sides that are parallel to each other. My height is 5 and divided by 2. So it looks like I've got 20 times 5 cut in 2. 20 times 5, think about it like $20 bills. If you have 5 $20 bills, you've got $100. Cut in half, and we see that we also get 50 as well. Okay, so either way is fine. A lot of these problems you can approach in different ways. Some of them will be a little faster, but these were generally, pretty close to the same amount of time. So I don't think there's a huge advantage in one over the other. Let's look at the back problem. This one I would say is more of kind of your mixed level. And this one, what I did was I kind of broke it up into steps. Oftentimes, all the question would ask you to do is kind of the last part, find the area of the shaded region, right? What I did was I kind of broke it up into what steps you'd have to do in order to get that little bit of shaded region. So remember, in this case, we always look at our triangles, right? Here's my triangle right here. And they told me that the side length is 10, so if I was to redraw my triangle, right, I've got the height, my side length is 10. And remember, if this is a hexagon, right, 6-sided figure, 6-sided polygon, and it's regular, all sides are equal, if I take the 360 degrees that are going to be in the middle, right, a full circle is 360, if I divide it by 6, I'm going to get 60 degrees. So each of these chunks is 60 degrees. Remember, this does not work for all polygons. If I had a pentagon and divided by 5, I would get something different from 60 degrees. So I want you guys to always think about, like, can I use this trick? Yes or no? And what I'm referring to by the trick is if my upper angle was 60 degrees, I've now cut that in half. So really, this is going to become 30 degrees, which makes this a 30, 60, 90 triangle. If I focus just on my little triangle on the side here, we can quickly see that the bottom is 5 because I've cut my 10 in half. If I want the height of my triangle, right, that's this yellow side, match it up here in the picture. Oops, sorry about that, guys. If I want to find the height, remember you've got to use your 30, 60, 90 rules. So 5 to get to my height, or my altitude, you have to do times root 3. So my height here is going to be 5 root 3. So I've answered step 1, part A. What is the apothem, or height of my triangle? It's 5 root 3 tall. Step 2, it kind of breaks it down for you. So it says, okay, you found the height. Now can you find the area of my triangle? And I definitely can. I've got a base of 10. My height that is perpendicular to my base is 5 root 3. So if I do base times height divided by 2, base is 10, height is 5 root 3. divided by 2. And I'm going to write my answer in terms of the square root of 3, just so I don't have to do any rounding. So I can just do the 10 times the 5. So I'm saying there are 10 5 root 3s. That means there are 50 5 root 3s. If I divide by 2, I can also do the same thing and just do the 50 divided by 2. And I'm going to get a 25 root 3. Okay, and I'm going to leave it like that just because my answer, if I leave it in terms of the square root of 3 and don't round, it's a little bit more exact, a little bit more precise. This is really similar to leaving your answer in terms of pi. So now I found the area of one of those triangles. One of those, if I look at the original picture, 6 triangles that makes up the hexagon. If I want the total hexagon and each triangle is the same, I can do 25 root 3, which is area of one triangle, times 6, which is my number of triangles. And I'm going to do 6 times 25. Right? If you think about money, 4 25s makes 100. 2 more is 50, so it's 150 root 3. Once again, I'm going to leave my answer like that just because I don't want to do a lot of rounding. Then I want the area of the circle. And I'm going to go back to my picture and kind of erase a little bit of stuff. So if I want the area of the circle, right, I know, if I kind of think back to circles, I know I need the radius. And here's an example of the radius. So it's one of my sides in my triangle. Now, if you think about these triangles that we made, right, the top was 60 degrees. Remember how we cut and we saw it was a 30, 60, 90 triangle? Right? If all the angles are 60 degrees, that means it's an equilateral triangle. So that means it's an equilateral triangle. And if your side was 10, that means all of your sides of your triangle are 10. And that means you can infer that the radius is 10. So if I want the area of a circle, that's going to be pi times radius squared. So pi times my radius is 10 squared. 10 times 10 is 100. I'm going to write my answer as 100 pi. Now the very last step is putting it all together. We found our area of our triangle. We used that times 6 to get the area of the hexagon. We found the area of the circle. If I want the shaded region, the bigger outer bit is the circle. So I'm going to do the circle minus the hexagon. And that's going to be 100 pi. Take away 25 root, excuse me, I'm looking at the wrong answer line. The area of the hexagon was 150 root 3. Now you might be looking at that and saying, whoa, 100 is smaller than 150. That doesn't make sense. Remember that I still have to multiply by pi and by root 3. So at this point, now I'm going to use my calculator. Now I'm going to round it. What I have written already, this would be your exact answer. Or the decimal answer would be 100 pi. And I'm going to do that. And that makes sense, right? Because if I'm doing 100 times 3.14, it makes sense that you would move the decimal place over a couple spaces. So I'm going to do that minus, I'm going to put in parentheses, 150 times the square root of 3. Now, I'm putting parentheses around all that, and I'm doing that in just a couple steps. You might have to multiply them out and then round your answer and write it down. That's fine, too. It looks like we are at about 54.35 units squared. I'll put that in both my answers. Now notice I didn't really have to do units squared throughout the work as much. I just kind of did it at the final answer. If I wanted to be a little bit more precise for each of my areas, I probably should have put units squared. But I was kind of thinking of it more like our final answer was down here, so I kind of waited until I got to the very end of it. Okay, so that is the quiz. So make sure you've tried it on your own, right? You tried the problems, you saw kind of where you had difficulty. So like I said, the first page, these 3 first problems are really, really core. I would say the back page is like your mixed level page. And this one was really broken up for you guys. So like I said, on an assessment, I would probably be more likely to just say, find the area of the shaded region. I probably wouldn't break it down for you quite so much on an assessment, but in this case, it's broken down more so on the quiz, just so I can see where you have trouble. With that in mind, your homework is going to be working on the study guide, right? Working our way towards the assessment, which I'll let you guys know what the take-home assessment will look like soon. So try out the study guide. That'll be the homework for the next couple of days. Okay.